With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone. So today we are going to discuss one question on circles. So here in this question, we are given that the circumcenter of the triangle ABC is given to us in this question as a point A. Then in such a case, we need to prove that the sum of the angles, the angle OBC plus the angle BAC is equal to 90 degrees. So here we are given this figure. So let us first try to visualize this question by using this diagram. So here we have this triangle ABC and the circumcenter of this triangle is this point O as shown here in this diagram. So here for doing this question we have already done some constructions. Here we have joined the points O and the point B and the point O and the point C. And here we have also dropped one perpendicular from this point O to this chord BC, that is the base of the triangle. And here we have named these four angles as the angle 1, 2, 3, 4 as shown here in this diagram. And now we are going to use one property of the circles. We know that whenever we drop the perpendicular from the center of the circle to any chord, then that perpendicular would bisect the given chord. So here we have the property as the perpendicular drawn from the center of the circle, to a chord bisects the given chord. So let us say that this is the property 1. So by using this property 1, we can say that the OD, that is this perpendicular, would bisect the given chord, that is the chord BC. So here we have the BD as equals to DC. So by using this result 1, we have the BD is equals to DC. Now here we are going to consider the two triangles. We are going to consider the triangle ODB and the triangle ODC. So here in the triangle ODB and in triangle ODC, in both of these triangles we can see that here we have the OB is equals to OC because both of these are the radius of the circle. So here we have the OB is equals to OC, the OB is equals to OC is equals to R. This is the first conclusion. And here we can also have that the OD is common here in both of these triangles. So here we have the OD is equals to OD because it is common in both of the given triangles. And we can also see that here we have the BD is equals to DC as we have proved here. So we also have the BD is equals to DC as proved above. So by using these three conclusions, we can conclude that by using the three conclusions, by using the SSS congruency property, we can say that the triangle ODB is congruent to the triangle, here we have the ODC. So here we have proved that both of these triangles are congruent to each other. Now since here both of these triangles are congruent, so we can say that from this statement, by using the CPCT, we have the angle BOD is equals to the angle COD. So here we have the angle BOD is equals to the angle COD. So here we have the angle BOD as angle 1 and we have the angle COD as angle 2. So from this we have concluded that the angle 1 is equals to angle 2. So here if we assume that both of these angles are equals to theta, then it would be theta here and this angle 2 would also be equals to theta. Now here we are going to consider the triangle ODB. So here we are going to consider the triangle ODB, and in this triangle we are going to apply the property of the triangle that sum of all the angles of the triangle is equals to 180 degrees. So here if we apply that property, then here we get the angle 1 plus the angle 3 plus this angle ODB. The angle ODB is equals to 180 degrees. So from this, if we solve this, then we get the angle 1 as theta, which we have assumed here. So angle 1 is theta plus the angle 3 plus the angle ODB. So here we have the angle ODB as 90 degrees because this is the perpendicular which we have dropped from this point O, that is the center of the circle, to this chord BC. So this angle is 90 degrees and this would be equals to, here we have the 180 degrees. So if we further solve this ahead, then we get the angle 3. So the angle 3 would be, here we have the 180 minus 90, that is 90 minus this theta. So here we have the 90 minus theta is angle 3. So we have got this angle 3 as 90 minus theta. So now we are going to use one property of circles. We know that the angle subtended by the given chord to the center of the circle would be the twice of the angle which is subtended at circumference of the circle. So here we have the property as the angle subtended by a given chord at the center of the circle is twice in magnitude to the angle subtended by the same chord at the circumference of the circle, at the circumference of the given circle. So let us say that this is the property 2. So by using this property 2, if we consider this BC chord here, then here we have this BC chord is subtending an angle of angle BOC at the center of the circle, and this angle BOC would be the twice of the angle BAC, that is the angle subtended by this chord BC at the circumference of the circle. So by using this result 2, by using this property 2, we can say that the angle BOC would be equals to the twice of the angle BAC, So here we have the angle BOC is equal to twice of the angle BAC, and here we know that from this diagram we have the angle BOC as the angle 1 plus angle 2. So here we have the angle 1 plus angle 2 as the angle BOC, and we know that the angle 1 plus angle 2, here we have the angle 1 and angle 2 is equal to theta, which we have assumed here. So here we have the twice of theta. So from this we have concluded that the twice of angle BAC is equal to the twice of theta. So here we have the twice of angle BAC is equals to the twice of theta, and from this we can conclude that the angle BAC would be equals to theta. So here we have got the angle BAC, that is this angle is equal to theta. Now in the question they have asked us to prove that the OBC angle plus the angle BAC is 90 degrees. So let us consider them. So here we have the angle OBC. So here we have the angle OBC plus the angle BAC. So the second angle is BAC. So if we sum them up, then we should get the 90 degrees. So here we have the OBC angle, and the OBC angle is 90 minus theta, which we have concluded here. That is the angle 3. So instead of this OBC, we write the 90 minus theta like this plus the angle BAC, and here we have the angle BAC is equals to theta, which we have just got here. So angle BAC is theta. So here we write theta. So if we solve this, then this minus theta and plus theta gets cancelled out, and we finally get the sum of the angle OBC plus the angle BAC. The angle OBC plus the angle BAC is equals to 90 degrees. So that is what we need to prove in the question, and here we have proved the same thing. So this is our solution. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.